Welcome to today's statistics tutorial on mean, median, and mode, measures of the center of data, brought to you by Caz Academy. The three measures of the center of data are mean, median, and mode. The mean is the average data value amount. This is going to be the center value when you add up all of the value datas. This is going to be the center. The median is the middle position data value. This is the data value that sits in the middle of your data. And the mode is the most frequent data value, or the value that repeats the most in your experiment. So let's look at a couple of examples to see how do we solve for each of these three measures of data. Okay, let's look at our first example. Our first example says, find the mean, median, and mode for the sample 1, 1, 2, 3, 3, 3, 3, 5, 5, 6. So let's begin by solving for the mean. So the mean is going to be the average or center value of all of our data. And the way that we calculate this is we get the summation of all of the data points and divide it by the sample size. So to get the summation of the data points, all that means is we're going to take all of these data and add them together. So that's going to be 1 plus 1 plus 2 plus 3 plus 3 plus 3 plus 3 plus 5 plus 5 plus 6, all divided by the sample size. Now in this problem it doesn't tell us how big our sample size is, but they did list out the data, so all we have to do is count the number of data points, and that's going to tell me how big my sample is. So that tells me I have 10 data points, so my sample size n is going to be 10. So now I'm going to plug this into my scientific calculator. You want to remember, if you're using a calculator to add everything, you want to put a parentheses around all of the functions of the numerator before you divide by the denominator. So let's go ahead and plug that into our calculator. We're going to go parentheses 1 plus 1 plus 2 plus 3 plus 3 plus 3 plus 3 plus 5 plus 5 plus 6. Then I'm going to double check that I have all of my values, and then close my parentheses. It's really important that when you're adding or doing any type of function that has a lot of numbers, double check that you have input it into your calculator correctly as you go through step by step. That's going to help to avoid getting problems wrong just because you inputted the values incorrectly into your calculator. So we divided by our sample size of 10, and that gave us a value of 3.2. So the mean value for this sample is going to be 3.2. The other way that you can solve for this is by using a frequency table. And with that, that is where we write down the values that we have. So we've got 1, 2, 3, 5, and 6. And then we're going to write down the frequency. And the frequency just means how many times does this number appear, or how often does this number repeat. So we've got 2 1s, 1 2, 4 3s, 2 5s, and 1 6. So the formula for solving for the mean when you're using the frequencies is going to be the summation of the x values times their frequency divided by the summation of their frequencies. So if they gave you just this frequency table rather than listing them out, then you can use the summation of the frequency, which is just adding this column here, and that's going to equal your sample size. So let's go ahead and write that out. That is going to be, we're going to multiply each of those. So we're going to take the x value 1 times its frequency of 2 plus 2 times 1 plus 3 times 4 plus 5 times 2 plus 6 times 1. That's going to be all of our values. And then we know that our sample size is 10 because we added it up from above. But if they hadn't given it, then we were going to want to add this column of frequencies and add those together. So that's going to be 2 plus 1 plus 4 plus 2 plus 1. Okay. Now we're going to input this into our calculator. Once again, when you're inputting it into your calculator, you want to put brackets around everything in the numerator and brackets around everything in the denominator. So let's go ahead and do that. So first I'm going to have a double bracket. Notice there's a double bracket. And then I'm going to put in all of my values. And you'll notice that I accidentally hit a 0 in times 1 instead of a 6. So that's just going to give me a value of 0. Let's see if it will let me. It's not going to let me delete that, but that's not going to change my equation. So I can just go ahead and add that 6 times 1 parentheses. Then I want to double check that I have all of my numbers correct. 6 times 1, 5 times 2, 3 times 4, 2 times 1, and 1 times 2. So I've got all of my values, plus I have this extra value, 0 times 1, which is just going to give me a 0, so I can leave that. That's not going to change my problem. If that calculated to be an actual number, then I would want to clear it and start over. So I'm going to put my second parentheses, divide by, then a parentheses, and I'm going to put all of these numbers on the bottom. So 2 plus 1 plus 4 plus 2 plus 1. And that should be everything. 2, 1, 4, 2, and 1. Everything looks good, so I'm going to close that parentheses, hit my equal sign, and once again I get another 3.2. Okay, so these are two different ways that you can solve for the mean, which is your center value or average. If the first way, and if you have just a small number of data, then it's not a big deal just to add them up individually. But if you have a large sample, then you're going to want to use a frequency table. The mean, if you have a sample mean, the notation is going to be x bar. And if you have a population mean, the notation is going to be the Greek letter mu. You solve for both values exactly the same, and your problem is going to tell you whether or not you're using a sample or a population. And we can see here that this is telling us we're using a sample. So that means our final answer would be the x bar equals 3.2. Now let's look at the same problem, and this time we're going to solve for the median. And the median is the middle position, or the data value that is in the middle position of the data. And the median is notated by the symbol, the large letter M. The first thing that we're going to do is we're going to find the location of the data. So that's going to be the sample size plus 1 divided by 2, and this is going to give us the location, or the position of the location of the median value. So once again, we're going to count to see how many data points we have. We have 10 data points, so our sample size n equals 10. That means that's going to be 10 plus 1 divided by 2. That gives me 11 divided by 2 equals 5.5. So this is the location of the data point. So 5.5 is going to be right here. But 5.5 is not on an actual data point. So because of that, we're going to want to find the average of the 2 points that are before and after that location. So that means we're going to take 3 plus 3 divided by 2, which is going to give me 6 divided by 2, which equals 3. So this is the value. So that means our median M is going to equal 3. Now you'll notice in this particular problem, the two values that our location is in between, those are the same number, so that's automatically going to tell us that our data value is going to be 3. But if those were not different, then we would get the average. So this is how you would solve it if they gave you a list of data points and you don't have a whole lot of data numbers. Then finding the location is just a matter of counting the number of data points and finding the location. If they gave you a frequency distribution table, or if you had a lot of data value points, then finding the location position is a lot easier if we use a frequency table. So let's go ahead and see how to calculate that. So to create a frequency table, we're going to write down all of our values. And then we're going to write down the frequency that they appear, or how often that number shows up in my data set. So let's take a look at how to use that. So the first thing is, since we already have this listed out, let's look at finding the position based on the value. So to get the value, we're going to take the value, and then we're going to write down its position. So let's start with the value 1. That is occupying positions 1 and 2. And we'll use this color just to break up. So these are all the boundaries that we're going to break up. So 1 occupies positions 1 and 2. The data value 2 occupies position number 3. The value 3 occupies positions 4, 5, 6, and 7. The value 5 occupies positions 8 and 9. And the value 6 occupies the position 10. Now we can easily see this when they're written down in a row, but if we were just given the frequency table, then there's a trick for easily figuring out what is the range where each of these data values fit in. So let's use our frequency table. So for the first one, we're going to write down 1. And then to figure out the lower end, we're going to take the number 0 and add 1. That's going to be my lower boundary. And then to get my upper boundary, I'm going to take 0, because I haven't added anything yet, and I'm going to add whatever this frequency value is. So that's 2. So my first position is going to have a lower boundary of 1 and an upper boundary of 2. And we can see that that matches what we previously got. Now we're going to look at the x value of 2, and we're going to start where we stopped. So we stopped at the upper boundary of 2, and we're going to add 1 to get the lower boundary. So that's going to be 3. And then to get the upper boundary, I'm going to add the frequency, which is also 1. And that tells me it just has the one value, which is 3. So now I'm going to do the same thing for 3. I want to get the lower boundary, so I'm going to take this 3 that's in that box with the 2. I'm going to add 1. That's going to give me 4 as the lower boundary of for the 3 value. And I'm also going to take that 3 and I'm going to add that 4, because it has a frequency of 4 to get 7, and that's going to be the upper boundary. Then I'm going to do the same thing for 5. I'm going to take that 7 and add 1. That's going to be the lower boundary for my 5. And then I'm going to take a 7 and add 2, because it has a frequency of 2 to get the upper boundary. And then I'm going to do the same thing for the last one. I'm going to take that 9 and add 1. And that's going to give me my lower boundary. And this has a frequency of 1, so that means that the lower and the upper boundary are going to be the same number. Okay, so you can see that when we did it by adding the frequencies, we got the lower and upper boundaries of what we had previously calculated by looking at it all listed out. So in the brackets are the possible positions, are the positions that each of those values carry. So now what we're going to do, so now that we have figured out the positions, then we solve it exactly the same way that we did before. And let's say, so once again, let's say they just gave you the frequency table. Then if I want to find out what n is, my sample size is going to be the summation of the frequencies. So all that is adding up the frequencies. So let's add that. That's going to be 2 plus 1 plus 4 plus 2 plus 1. And when we add those all together, that's going to equal 10. So we're going to solve it the same way that we did before. Now that we've got the sample size from our frequency table, we're going to take our n plus 1 divided by 2. So that's 10 plus 1 divided by 2 equals 11 divided by 2 equals 5.5. So once again, this is the location. So I want to know out of these boxes, which box is going to contain this number 5.5. So I know that 5.5 is going to be right here. It's going to land right here in between the 5 and the 6, which tells me that 3 is going to be my middle value. Okay, so those are two different ways that you can solve for the median, which is the middle data value position. Now let's look for the third item, the mode. And the mode is just looking at which data value repeats the most or is the most frequent data value. And that is going to be the easiest because all you have to do is you have to look at the listed number of data and look at which value repeats the most often. So we can see that the 3 repeats 4 times, which is more than any of the others. So that means our mode is going to equal 3. If I have a frequency distribution table, we're going to do the same thing. So let's write down our distribution table with our frequencies. This was 2, 1, 4, 2, and 1. And once again, you're going to do the same thing. You're going to look and say which one has the highest frequency or which one has the number where the number is the biggest on the frequency. And that value, the corresponding value, is going to be your mode. So both of these are giving me a mode equals 3. Okay. So that's how you're going to solve for mean, median, and mode when they give you a sample where it's all listed out. So now that we have calculated the mean, median, and mode for the sample, let's take a look at how they relate to each other so we can just kind of visually see what do they look like. So the mean for the sample, we got 3.2. This is the center value or average of for the median. We got a value of 3, and this is the middle data point. And the third thing that we got was the mode, and this was also a 3, and this was just the data point that repeated the most. So if we were to graph this, just so we can visually see what does this data look like, we're going to put the frequency here, my x values down here. Got 1, 2, 3, 4. Oops, looks like I didn't give myself enough room. One, 2, 3, 4, 5, and 6. So this is my x values, or the values of my data. This will be 1, 2, 3, 4, 5, and then we'll just do a dot plot to show how often each of these are showing up in my data. So this is what my distribution of my data, of my sample, is going to look like. And then we can see on this our mean is going to be about right here on my graph. The median is going to be right here on the 3, and the mode is also going to be occupying this position on the 3. So you can see these values are all pretty close. They're all centering or closely around 3. When you have a relatively uniform distribution, those numbers are all going to be pretty similar. But just depending on how your data is distributed, that's going to affect what these actual values are. Sometimes they have the possibility of all being the exact same number, or they might be different. But usually the numbers are pretty close, and depending on what it is that you're looking for or evaluating is going to depend on which of these 3 centers of data that you're going to be using. Let's look at the next problem. This one says find the mean, median, and mode for the sample using the frequency distribution table. So let's begin by solving for the mean. To solve for the mean, when we have a frequency table, we're going to take the sum of the x values times their frequency divided by the sum of the frequencies. So on the top, we're going to have 1 times 25 plus 3 times 15 plus 5 times 8 plus 10 times 10 plus 12 times 2. That's going to give me the sum of all of the x values. Then I'm going to sum the frequencies. That's going to be 25 plus 15 plus 8 plus 10 plus 2. When I sum all the frequencies, that's going to give me the total number of data in my sample size. So let's go ahead and plug this into our scientific calculator. So once again, we want to bracket the numerator and bracket the denominator, so all those functions are included when I plug them into my calculator. I'm going to do the double brackets. 1 times 25 plus 3 times 15 plus 5 times 8 plus 10 times 10 plus 12 times 2. Then I'm going to double check that I have all of my values. I've got 12 times 2, 10 times 10, 5 times 8, 3 times 15, and 1 times 25. So I have all of my numbers. I'm going to close my bracket, and then I'm going to divide by the sum of the frequencies. So I'm going to do my brackets, 25 plus 15 plus 8 plus 10 plus 2. Double check that I have all of my numbers written down correctly. Close my parentheses, equals 3.9. And this is a sample So that means my sample mean is going to equal 3.9. Now let's solve for the median. So to get the median position, we're going to take the sample size plus 1 divided by 2. Now our problem didn't give us the number of data in our sample, so we're going to need to calculate that by adding the frequencies all together. So let's go ahead and put those in our calculator. That's going to be 25 plus 15 plus 8 plus 10 plus 2 equals 60. So we have 60 data points in our sample size. So now we can come up here and say 60 plus 1 divided by 2 equals 61 divided by 2 equals 30.5. So this is the location of our median, which is the middle data point. So now the next thing we need to do, since we don't have our data all written out for us, we can't just count it. We need to figure out which of these x values are occupying which positions so that we can find this 30.5 position and identify which data is associated with it. So we're going to start with our data value number 1. And we're going to start with 0 and add 1 for its lower boundary. Then we're going to take 0, and we're going to start with 0 because that 0, there's nothing there. Then we're going to add the frequency, which is 25, to get the upper boundary. So that means that the data value of 1 is occupying all of the positions between 1 and 25. Now we're going to do the same thing for the value of 3. I'm going to take this value where I stopped, which is the 25. I'm going to add 1 to get the lower boundary. And then I'm going to take that 25 again and add the frequency, which is 15. And that's going to give me my upper boundary. So 25 plus 15 is going to give me 40. And then I'm going to do the same with my 5. I'm going to take that 40 and add 1 to get my lower boundary. And then I'm going to take 40 and add it to the frequency of 8 to get my upper boundary, which will be 48. And then the next one is a 10. So I'm going to take my 41 and add 1 to get my lower boundary. And then take the 41 and add the frequency, which is 10, which is going to make that 51. And then I have my last value point. Oh, I see what I did wrong. I took on this last one on 10, I'd use the lower boundary rather than the upper boundary. So you always want to use the last upper boundary. So let's try that again. So the upper boundary is a 48. We're going to add 1. That's going to equal 49. Then we're going to do the 48 again, and we're going to add the frequency of 10. That's going to give me 58. And then I'm going to do the last one, which is my 12. I'm going to take that upper boundary of 58, add 1, which is going to give me a 59 for my lower boundary, and then 58, add a frequency of 2, and that's going to give me 60. One of the ways that you can check that you've done this correctly is that your last position should equal the total number of your sample size. And that's where, when I was doing, as you saw just a moment ago, I caught that I was making an error on this 10, that I had used the lower boundary rather than the upper boundary to move forward, and that was making my data incorrect. So now I have the position spread, or the data spread, for each of those values. So now the next thing I want to do is I am looking for a location of 30.5. So I'm going to look in each of these and say, where is 30.5 likely to be? And I can see it's going to be right there. The position of 30.5 is going to be somewhere in there between 26 and 40. So that tells me that 3 is going to be my median. So M is going to equal 3 for this frequency distribution for this particular sample. Okay, and then for the last item, we're going to look at mode. And when you have a frequency table, the mode is super easy. We're just going to look at this row of frequencies and look at which one is the largest. And we can see the largest is at 25. So that tells me that my mode is going to equal 1. And that's it. That's how you solve for the mean, median, and mode for a sample using the frequency distribution table. That concludes our tutorial on mean, median, and mode. I hope you found this helpful. Appreciate you watching my videos. See the links below for additional supports and resources, and be sure to like and subscribe to get the latest videos from Caz Academy. Thanks for watching, and I will see you at the next video.